All right, let's go ahead and get started. Hey everyone, thank you so much for coming. Last session of the day. I know you're all probably tired, but we got a lot to cover today, so let's get right into it. Welcome to a JavaScript crash course from an Apex developer's point of view. My name is Sean Cuevo, and I am a senior member of technical staff at Salesforce.org. Before I begin, our favorite slide here, just a quick note that you should base your purchasing decisions on products and services that are currently available. A little bit about me before we start. I've been in software development for about 8 years now. Most of that time I've been working on the Salesforce platform, but I've also had the opportunity to work on projects using Golang and Ruby, and of course JavaScript. Now, just like the languages we use to speak to each other, part of successfully using a programming language is to embrace the nuances that are commonly accepted by other users of that language. In other words, stop developing in JavaScript as if you were writing Apex. So here's a little bit of an agenda of what we're going to go through today. Just some of the foundations of what I think are necessary for an Apex developer to write JavaScript, how JavaScript compares with writing Apex, and hopefully that'll give you a foundation to build from. We'll start with a comparison on typing and scoping in JavaScript and Apex and the side effects of those differences. Then we'll jump into how JavaScript supports first-class functions and how that influences the way you write your code. Then we'll spend a lot of time demystifying the this identifier. Afterwards, we'll jump into some debugging tools, do a little demo, and some interactive debugging that's available in JavaScript but not in Apex. And afterwards, we'll share a few resources and jump into Q&A. All right, let's get into it. So the first thing, a very key difference is that JavaScript is dynamically typed while Apex is static. When you have a statically typed language like Apex, variable types must be declared in your code, and those variables can only hold those types. In this first method here, on the top here, you see that the parameter x can only be an integer, and the method can only return an integer. See, static typing provides a level of protection at compile time, as there is a stricter contract as to what your method will accept and what it will return. This leaves a lot less surprises because you know exactly what your method should do. Now, in a dynamically typed language like JavaScript, variable types are defined at a runtime. So in this function below, the parameter x can be anything. X can be a string, an integer, an object. You don't necessarily know what it'll return just by looking at the function itself. And while you're giving up some of that safety you get from compile time protection, you also get a little flexibility as a result. Now in JavaScript, returning arbitrary data types is very simple. You can just declare them in line and create them. Here's an example of a function creating an arbitrary object with some nested data in it. So you can just, right there in my method, I create and return an object with a bunch of random keys. One of those keys has a nested object in it, which has a string in it. I can't count the number of times when I'm writing Apex where I needed to process some data and return some arbitrary data structure, but you run into the issues you get in a statically typed language. To achieve the same in Apex, I would have to define the objects that follow the data structure that I want. Now, this is kind of a contrived example, but to mimic that object I created, I had to create this random data structure where I had two properties that were strings. Then I had to create this data structure to represent the nested data. Then my method had to build the top layer, build the nested data, populate all the data, and then return that. You do get some type safety here. You still get that, but if I was just using this in a private helper method in one place of my code, it's not really worth the type safety since you're controlling the inputs and the output of your code. So while you get type safety, you also get some extra code that you now have to write and maintain, and it's not really worth it. Now, you may be thinking, yeah, you can do the same with a map with strings, like a map of string to object. And while this is shorter, good luck parsing that later. It's going to create some more problems down the line. But when you have dynamic typing, you can also get some unexpected results. Take this JavaScript function concat. Basically, the intent is I take two parameters, A and B. I'm going to concatenate them together and log them in the console. So if I pass it hello and world, it should output hello world. And then when I pass it 1 and 2 as integers, I expect it to output 13 because that would be the concatenation of the string 1 and the string 2. But because this is a dynamically typed language, it doesn't know that they're supposed to be strings. It interprets its type at runtime. So to fix this, the second concat function actually puts an empty string in between A and B before it concatenates them. It forces it to, it coerces the integers to act like strings. And as a result, if you pass it 1 and 2, it outputs 12 as expected. So you have to remember when you're writing JavaScript, with this added flexibility, you do need to be a little more defensive in order to prevent unexpected results. Now let's jump into differences in scoping between JavaScript and Apex. In short, you can think of scope as the visibility of variables in your code. In other words, where can a variable be referenced within your code? In Apex, it's pretty straightforward with block scoping. You can think of a block as anything between a pair of curly brackets. Basically, in Apex, scope flows outward. When a token is used in a block, the compiler searches within that block for its definition. If it can't find it, it searches outside of that block to see if it's a static or an instance property in that class. And if it still can't find it, it checks the global scope for things, in the global scope, you have tokens like test and schema and database. If that fails, then you get a compilation error. Pretty straightforward. And as you're going to see as a common pattern in JavaScript, scope depends on the context and how you're using it. You're probably most familiar with the var declaration. The declaration of your variables is going to affect how your scope works. var has what's called function level scope. If you define a variable with var, or declare a variable with var, the entire function can see it. As you can see in this first function here, var my variable is declared within the block of that if statement. Now you would think, okay, only that if statement should really be able to access my variable. But as you see on line 5, when you console log my variable, it actually outputs hello because function level scope gives it access to that variable. To make things even worse, in the second function, I forgot to use the var keyword to declare my variable. Whereas in Apex, you'd get a compilation error saying it doesn't know what my variable is. Instead of throwing an error, it gets added to the global scope. Now my variable is actually visible everywhere. Fortunately, you can have your code throw an error in this case through the use of strict mode like I do in this third function. When you have strict mode enabled, then you get a reference error saying my variable is not defined in scope. Lightning Locker actually enforces strict mode everywhere in your Lightning code, so you don't actually have to declare strict mode. But it's important to understand what's going on here so that if you're working in a non-Lightning context, like writing, as you're now well aware, writing Lightning web components outside of Salesforce, it's important to understand what's going on here. With the introduction of ES6, you can now declare variables using the new keywords let and const. Both of these have block level scope, similar to how Apex variables work. So as you can see in this function, I have my variable and my variable 2 declared within that the if statement. And then when I try to log those variables outside of that block, it actually gets a reference error because it doesn't know it's defined. The difference between let and const is that let can be reassigned and const cannot. So const does not mean immutable, but it means not reassignable. In general, I prefer to use const first. If I need to reassign my variable, then I'll use let. And I'll only use var if it's necessary, so you don't have that weird function level scope. I find that you generally don't need var. For the most part, const and let meet most of your needs. Okay, so let's get into the real meat of this stuff. This brings us to first class functions, which is what I believe to be one of the key differences to the way that Apex in JavaScript is written. Now, unlike Apex, functions in JavaScript are considered first class. What does that mean? It means that a function can be passed as an argument to other functions, which are often referred to as callback functions. They can be returned as values from other functions. They can be assigned to variables, and they can also be stored as attributes in other data structures. In Apex, you can't really pass methods around like that. I mean, you kind of can when you encapsulate a method in an object and pass around that object and then call the method in that object, but that's not quite first class as you would see it in JavaScript. So here's an example of first-class functions in action. We have a function here called fetch a function, and all it does, it returns another function which just logs the text you called. I also have a function called execute a function that accepts a parameter and then calls that parameter as a function. So whatever is passed into that function, it just executes it. So I call fetch a function, and then it stores the result a function into the variable myfunc. Now the value of myfunc is a reference to that function. I pass that to execute a function, which then executes it, thus outputting you called. You're going to see this a lot in LWC, especially with callbacks and promises. Now here I've imported a submit records method from an Aura-enabled Apex controller. LWC imports Apex methods as JavaScript promises. Now, I won't get too much into promises, but that's what allows you to do that then catch functionality. And then and catch both accept functions as a parameter. These are the callbacks. I define those functions in line here, which is you'll often see when you're writing, working with promises. The callback that is passed to the then function just alerts success, and then the callback passed to the catch function alerts something went wrong. Now, I didn't have to define them in line there. Since they're first class, I could actually declare them somewhere else. So I declared handle success and handle failure outside of that function, and then I just pass references to those functions to the then and catch functions. I like doing something like this when my callbacks start getting really long. I often see callbacks, nested into each other, and then you have this long function, and it's hard to tell what's happening. So when that happens, I like to shorten it like this, so you know exactly what's happening, and in your mental map, you're like, okay, when this works, I handle success. When it doesn't, I handle failure, and you can move on. Let's take let's take a less contrived example. Let's say I have an array of contacts here, and in this array, in each contact, it has their name as well as a group that they belong to. Now, as a user, let's say I want to print out a concatenated list of all the contacts that belong to a specific group so that I can print them on a document to be delivered as an invoice. And so here's my array. If I were to write my JavaScript like I'm writing Apex, you would probably do something like this. So you'd initialize a blank string, use a for loop to iterate through all the contacts. If the contact belongs to a desired group, then concatenate their name to the string. Now on its face, there's nothing wrong with this. You can write this in JavaScript and it would work, and it would execute the behavior that we desire here. But you typically wouldn't see it written like this in JavaScript. Now, the JavaScript language has functions that you can call on array objects that take advantage of the idea that functions are first class. Here are three array functions that we can use to iterate here. Now, the filter function, it iterates over each value in a collection and passes each item to a callback. If that callback returns a truthy value, then the item will be added to a new array. Otherwise, don't add the item to the new array and move on to the next one. So it's filtering your array. The map function also iterates over each value in the collection, passes each item to a callback, where you can do some processing or transformation on that item, and whatever the callback returns, it will add it to the new collection. Reduce acts in a similar way to map, But instead of adding it to adding each returned item to a new array, it'll actually pass in an aggregator object into the callback, and then whatever that, you can do some transformation on the iteration there, and whatever that returns becomes the new aggregator. In essence, you're basically reducing an array into a single object. So here we go here. What did we do? We took our contacts array, we called filter on it, and that returns an array of contacts that are in the Avengers. And then we call map on that array, which then creates a new array of just the contact names as strings. And finally, we call reduce on that final array, which builds our concatenated list of names. This outputs the same thing as we saw before. Here's the same thing, but using arrow functions instead, which makes it even more concise. These are the kind of things you're going to see when you're writing JavaScript, and you want to be able to take advantage of them. I will say this is a bit of a contrived example as well. You probably wouldn't call filter, map, and reduce on this. You'd probably just do it all in that, filter and then map, and then not do that reduce. But in that sense, you're going to see this is just an example of how you can use all those array methods in a chained fashion. This is a common pattern that you'll see in JavaScript. You're going to call some function. You're going to get some data back. Then you use a callback to process that data. You'll see this in promises in LWC. Whenever you'll see this a lot when filtering and transforming collections. And inline functions are going to be everywhere in JavaScript. Because functions are first class in JavaScript, the execution of JavaScript tends to favor this pattern of passing around utility functions that execute logic as opposed to using instance methods to manage an object's state. I actually don't know if a for loop is more or less performant than the filter, map, reduce functions. In fact, I think I've read that the for loop is like a smidge faster. But if you're not processing like 1 million records, that benefit isn't really worth it. And remember, part of writing code is making sure that it is readable by other developers. As the saying goes, when in JavaScript, do as the JavaScripters do. And so that brings us to the this keyword. The this keyword has a very different meaning in JavaScript than it does in Apex. And it can be a very difficult concept to wrap your head around. I know I struggled with this a lot. I still struggle with this a lot. In fact, because the word this is inconveniently named, every time I'm going to refer to this as the identifier, I will say the this keyword. So if I just say this, that means that's just like the pronoun, or the word this is an adjective, pronoun, article, depending on how you use. Anyway, it doesn't matter. It's the this keyword is the code this. So here we go. Hang on. The this keyword in Apex is nice and straightforward. It refers to the current instance of the object. If you use the this keyword in a similar fashion in JavaScript, you will inevitably run into many problems because of the changing nature of what the this keyword gets bound to, because again, it depends. Whenever you look into the this keyword, it's often said that it's supposed to represent the call site. But what does that actually mean? Well, what the this keyword is bound to depends on the context in which it's used. Just by looking at a function that contains the this keyword does not necessarily give you enough information as to what it refers to. It's not necessarily the object or the function it is used in, but it could be. This really frustrated me, and it still frustrates me to this day, because I really wanted the this keyword to work like it does in Apex. But if you can let go of that notion of what you think that this keyword should be, you can embrace it for what it can do. Now, the first step to doing that is understanding how the this keyword is bound. Let's start with the default binding. And by default, the this keyword binds to the global scope. Basically, when the this keyword can't be determined, the compiler falls back on the global scope. However, if you're using just strict mode, which you will be when you're writing LWC, then the this keyword will be null and will actually throw an error instead. The next way that the this keyword is binding is what we call new binding. Now, when you call a function with the new keyword, you're actually invoking a constructor call of that function. So when you call a function with the new keywords, something special actually happens in that function. First, the function creates a new object. It's just there. Any references to the this keyword now represents that object. It's right here, this object. Nope. At the end of the function, unless something is explicitly returned by the function, the newly created object is what will be returned. So here we have a person function. The fact that it has a capital P doesn't actually mean anything. It could be a lowercase p, but it's a general convention that if a function has it starts with a capital letter in JavaScript, then it can and probably should be called with the new keyword. So let's take two executions of this function. First, we create a variable named Sean by invoking the person method with the new keyword. So new binding is in effect. We do the same for Joe, but we do not use the new keyword. So we just call it as a regular function. Now, Sean.name actually outputs something. It outputs Sean, because that's what we passed it to the constructor, and we use new binding, so this.name is in that object that became the variable Sean. Joe.name, however, does not work because the Joe variable was undefined. Because we didn't use the new keyword, that function actually didn't return anything. So now it's just an empty object, or actually it's just undefined, and we're trying to call name on an undefined object. So that covers the new binding. Next is explicit binding. In JavaScript, there are ways to explicitly set what this keyword should be. There are three ways to do this: call, apply, and bind. Call invokes a method. The first parameter is what you want this keyword object to represent. The next parameter, or parameters, you can pass in as many as you want, are the parameters you would actually pass to the function itself. Apply is the same, except instead of listing out all your parameters, you can put all your parameters in an array, and then it'll handle spreading them out for you. That's usually useful when you're using a function that has many parameters in it, and you don't want to have to list them all out. In short, bind, however, works a little differently. Bind accepts one parameter, what you want this keyword to be. And when you call bind on a function, it returns that function with this keyword already bound, so you can use the method later, and it's already explicitly set what this keyword is bound to. So in short, use call and apply when you want to invoke a function with a specified this object, and use bind when you want to specify this keyword, but want to call the method a little later. Let's take an example. I have a function called identify. It accepts a greeting and it outputs the greeting and the name property of what this keyword is bound to. Now, when I use call on that function, I pass to it what I want this keyword to be. In this case, the object named Sean. And then it then outputs hello Sean, because this keyword is bound to the Sean object, which has a property name that has the value Sean. I can do the same thing with the Joe object. This time I'm using apply. Pretty much the same thing, but you'll notice I'm passing it an array of parameters. It's only an array of one, but it still works. Same thing, and this time it says morning Joe. And then lastly, I use the bind function to bind identify to the Sean object, and then I store that into that variable bound function, so I can call it later. And then I later call bound function with the greeting evening, and then that outputs evening Sean. In general, I like explicit binding. I think being explicit leads to clearer code, and like the less you have to guess, the better for everyone, especially you who will inevitably look at your own code in 6 months and say, who wrote this? Oh, it was me. Now, the next one is implicit binding. When an object has a function as a property, and that function is called directly on the object, the this keyword is that object. This is what is called implicit binding. This is a little easier to understand with an example. So I have an object called Sean again that has two properties, name, which holds a string, and identify, which points to a function that outputs this.name. And then when I call Sean.identify, it outputs hello Sean because implicit binding is in effect. So this in that case is, oh, it's the Sean object, so let's output hello Sean. Actually, in this case, it would just output Sean because it doesn't say hello in the code. But you get my point. Now, there's some danger with using implicit binding because you can actually break that implicit binding. Let's take the Sean.identify function, and I'm going to assign it to identify loss as a variable. Remember, functions are first class, so you can reassign functions all you want. When I call identify loss, it outputs undefined because the implicit call site has been lost. It doesn't know what this keyword refers to anymore. You probably won't see this very often, but it's again, one of those important things to know how this thing works. You're going to see this a lot in LWC as well. Here I have a simple handle click method that marks a tracked property as true when it's called. At first glance, this looks like this keyword works like it does in Apex, and everything's happy. It's like, yeah, see, this job running, because it has a job running property, so that's why it knows what it is. But the only reason this works is because when we call the handle click method, implicit binding is in effect. Let's take the same function, but this time I'm going to set job running inside another function. I'm just going to nest it inside and put it somewhere else. When we call handle click, that calls mark job running. However, mark job running is not being called with new binding, so new binding is not in effect. We're not explicitly binding it, and it's not being called off of an object, so implicit binding is not in effect. So as a result, it's going to try to use default binding. Of course, since LWC runs in strict mode, default binding won't work. So instead, we're going to get an error saying, cannot read property job running of undefined. Whew. So how do we determine what this keyword is? Just follow this hierarchy, with each step taking precedent over the next. First, is the function being called with new? If it is, new binding is in effect, and this keyword is bound to the newly created object by the function. If that's not the case, are we using call, apply, and bind? If we are, then explicit binding is in effect, and then this is the specified object. If that's not the case, are we invoking the function off of an object by calling foo.myfunction? If it is, then implicit binding is in effect, and the function was called from is this keyword. Otherwise, it's in the global scope, and if it's in strict mode, it's probably undefined. Now that you've started to understand all of that, I'm going to throw one more wrench in here. Arrow functions. Arrow functions are actually not just shorthand for writing functions, and this keyword actually behaves differently inside of them. So it's not the arrow function is not just syntactic sugar to make it easier to write functions. It actually changes behavior. Let's go through an example to see what this means. Let's take a look at this person function. So in this person function, it basically, when the constructor is called, we create an object that has a name and a delayed greet. So instead of just saying the greeting, it's going to pass a function to a set timeout, which just calls the function later after 100 milliseconds, and then logs, hi, my name is whatever this.name is. Now when we call this function, this is going to output, hi, my name is undefined. Now looking at this, I'm like, what? Why didn't that work? I called it with new binding shouldn't be in effect. And while that's the case for this.name and this.delayed greet, when this is actually a callback function that gets called by setTimeout. So new binding isn't in effect when this is called. In fact, it's going to fall back to the default binding and output something else. In this version of the method, all I've done is replace it with an arrow function. Instead of using the word function, I have the arrow function here. When I call delayed greet off of Sean, it actually outputs, hi, my name is Sean. Why is this happening? Well, arrow functions have what is called lexical this. When you use an arrow function, instead of using the this hierarchy, it binds the this keyword to whatever the this keyword is bound to when the arrow function was assigned. So during the construction call, new binding is in effect. So when the arrow function is created, it continues to use that new binding for that callback. Are you confused? Anyone confused? You should be. This is, people claim that arrow functions fix this problem, but I actually think this makes it more confusing. If you follow the hierarchy, it makes sense because there's a set of rules. This just like, I actually don't know where this falls in the hierarchy. So again, I say be explicit. Just use function and then use the bind function so that you can explicitly set what this is. And then with this being the case, now you know exactly what it is, and now it's going to output, hi, my name is Sean, just like we want it to, and everyone, it follows the hierarchy as we like. So my advice, if you're you can use arrow functions. I encouraged you to do so, but if you have to use the this keyword, avoid using an arrow function, or else you could run into some unexpected behavior. All right, let's change gears a little bit, and we're going to hop into some debugging tools in JavaScript, and this is a little more fun. Now, in Apex, you usually debug with a combination of system.debug statements and system.assert statements, and then running the code and looking at the log or seeing where it crashes when it hits the false assertion. You can do the same in JavaScript using console.log, but as a result, you'd only be using a fraction of the debugging tools available to you. In Apex, when we debug, we run a thing and look at the aftermath. In JavaScript, it's all running in your computer, so you actually have more flexibility. Okay, let's jump into the demo. Okay, did anyone figure out what the bug is? What do you? Yes, yeah, that is the bug. So when hours is 17, which one should it really fall in? It'll fall into the second one, but it should fall into the third one. So anyway, I have a function here that when basically this little component, you click a button and it just outputs a greeting based on the current time. So we handle click, gets the hours from the date, and depending on what time it is, says good morning, good afternoon, or good evening. So here it is. Let's hit that, and it says good afternoon. Well, that's weird. It's 5:30. That should probably say good evening. So how do we debug this? Now, if this was in production, and if it was Apex, you couldn't look at the production runtime unless you already had debug statements in there. You could open up the debug logs and try to divine what's going on, but that's still a little difficult. However, in JavaScript, if you open up the developer console, so I did that by doing inspect, and then it opened this up. I went to sources and opened up my code here, and also make sure that your running user is in debug mode, which you can enable from the settings, and then that'll show you unminified code. And what you can do here is click on the number that creates a breakpoint. I'm going to hit greet again, and it actually it gets dark and it freezes the code as where it is currently at, and I have access to that scope. So now I can say, it's like, all right, I can go to the console and I have the variable hours, and it's like, all right, what is hours set to? All right, it's set to 17. If you were trying to debug this live and you're like, you know what, I want to see what happens to this when it's 5 in the morning, you can actually set it to 5, right? And then when I hit play, it'll preserve that change and make it good morning. And then, like, as we pointed out, it's like, oh, the problem is that this is less than or equal to 17, and this actually should just be less than. And actually, I can change the code in line, save it here, run it again, and it'll put in the output good evening. You can also right-click on this and edit the breakpoint. So I say, I only want to do this when hours is equals 4. I really want to look at for a very specific use case. I put that in there, hit greet again, and it doesn't freeze because it skips right over it. That probably wasn't very useful in this context, but I really like using that when I'm iterating over a large collection. I only want to look at one instance. So like, I only want to look at when it got to a contact that wasn't the Avengers, and I want to make sure that, I want to look at that object, so I'm not like iterating through all of them. Let's see, 4 minutes, okay. So that's pretty much it in debugging. Oh, another thing you can do is you can actually, if you're developing, you can actually use debugger, and then it'll stop there if you have the console open. I don't want to actually run it, but yeah, it's another option you have. Okay, we're running short on time, but I did really want to show this. We're going to run this test. So I had this LWC just test, and I was like, you know what? I want to assert on the greeting output, but I don't know what attribute I need to look at. It actually turns out to be inner HTML, but while I was writing this, I was like, all right, I want to look at this object while it's running. So if you run test unit debug, see if we can do this quick, and then in the Chrome inspector, if you go to Chrome inspect, this will pop up because that's what the debugger has launched. Oh no. And then I inspect that. That's going to take a second to load. You could see it trying to do things in here. Come on. Oh, I got to hit play. Down to the wire. And then you can see that it's going to start loading stuff in here so that you know it's actually doing something. And then it'll hit my debugger that I put in there. Oh no, not this one. All right, here's the debugger. So now I'm actually inside my test. And I can go to the console, look at the greeting output, and say, all right, I know it's like HTML something. Inner HTML. That's what I'm looking for. So definitely check out the debugger tools. Check out LWC Jest to run some like really good debugging, so you're not less constantly loading the page over and over again. In the slide deck, I actually just like go through doing all these things. So yeah, that's pretty much it. Here's so again, the general theme is with JavaScript, you might hate JavaScript, you might love JavaScript, but it's a tool you're going to have to use. So try to embrace the ways that it is written so that when you're looking at other people's code, you understand what they're writing. One of the coolest things about LWC Jest or LWC is, you're now writing more standard JavaScript. When you were writing an Aura component when it first came out, you were looking for documentation and probably couldn't find it. When this launched as a pilot late last year, I was able to debug my code because I was looking for JavaScript problems, not Salesforce JavaScript problems. So take a look at these trails. There's like that Learn to Work with JavaScript is a good one. I definitely recommend this book, You Don't Know JS. I based a lot of the content from this presentation on that book. It's a free ebook. It's all on GitHub. Same thing with Eloquent JavaScript. And of course, check out my blog at socoldprogrammer.com. All right, let's open it up to Q&A. If you have any questions, go to the microphone there. And then I'm going to hang out for a little bit too so we can chat as well.
So I'm just learning LWC, and I'm not really a JavaScript programmer. And the first thing that frustrated me is the objects. I want to see what shape LWC framework is passing into my JavaScript function, and it's a proxy. And it's really hard to look at. How do I look in those?
If you do JSON.stringify, So this one isn't a proxy, but if you do JSON.stringify, it turns it into a string, so you can just straight up look at the proxy object.
But then it's hard, now can I modify it?
Well, at that point, even though it's a proxy object, you can actually, it'll say, so in this example, it's not showing proxy, but you would be able to do you would be able to interact with it, even though it says proxy. So you can't look at the attributes, but they are there.
Thank you.
No problem.
Hi, in your example where you were calling another function in the class with this dot function name, you weren't putting parens after it. I've been using that and that works, but apparently it works without them as well.
Yes.
Is
so,
JavaScript just loosey-goosey on that?
So the way that works here, I'm trying to find that, whoops. Where was that? Oh, I know where that is. So the way that, when you don't have the parentheses, you're not invoking the function. You're passing it as a parameter. So in the callbacks, and then and catch, you're actually saying, okay, after my promise executes, then call this function later. So you don't, if you put the parentheses there, it'll actually call it then, right there, and then it'll just the parameter of what that function returns will be passed instead.
So if you were setting a value equal to that function, you wouldn't put the parens.
Right.
Okay, thanks.
All right, thank you so much. Thank you for coming out. I'll be here for a little bit if anyone wants to chat.